Okay, so this is a test 4 solution video, just to review the solution to this test. So let's start with question 1, simplify the following. And if we take a look at this question here, we're going to see that really we're just multiplying, so we have to use our laws of exponents. And we need to remember that when we multiply two things with the same base, such as this x here and this x here with the same base, or this y here or this y here, we have to add the exponents. So we start by multiplying the coefficients in front, and that gives us a -6 when we do the -3 times positive 2. So right away, choice C is ruled out. Then when you multiply x to the second times x to the first, that's x to the third. We have to add the exponents. So that means that choice D is now ruled out. And then finally, y to the fourth times y to the second, again, add the exponents, that becomes y to the sixth. So in the end, it is choice B. For number 2, the question says the following. Which of the following graphs correctly depicts the situation below? And we're taking a look here. A phone service A has a flat fee of $100 and then $10 for each phone line. So it's like getting a family plan. It's $100 a month, but $10 for each phone line that you have. Phone service B, though, charges $150 a month, but only $5 per phone line. So let's take a look. It means that there's going to be a starting value of 100 for this one, and it goes up with a slope of 10, so a pretty high slope starting at 100. And then this is a starting value higher, but a lower slope, so there's going to be a slope that doesn't go up as high. So the first one might have a slope looking like this, and the second one has a slope maybe looking like this, where it's not as steep. So here, this would first represent a starting value of 150 with a pretty high slope, and this would be a starting value of 100 with a low slope. So if these two numbers here were switched, this 5 and this 10, then this would be our answer. But again, the 150 has a lower slope, so the one that starts here should not increase this quickly. It should increase much slower. It should go much slower than the other one. The second one here, we can clearly see that they both start at 0, so this is not possible. Both of these have a flat phi in case, so those are like your y-intercepts, so this can't be it. Well, here it looks like it can be it at first, because this one is 150 a month, this is 110 or $100 a month, but this is showing that it's consistent depending on how many phone lines you have. So you could have up to 15 phone lines and still only pay $150 a month. But this tells us clearly that it's $10 per phone line additional, or $5 per phone line additional. So our final answer has to be this one, and let's take a look. $100 is cheaper starting, but it goes up at $10 per phone line. That's this right here. And this 150 to start only goes up $5 per phone line, so we can see that it goes up at a slower rate. So our answer would be choice C. Number 3, what is the domain of the function h of x equals the square root of 4 plus x? Well, we have to remember that our square root functions have got to be greater than or equal to 0. So we start by saying that the radicand must be greater than or equal to 0, because we can't have a negative number under the square root. That's imaginary. And when we're looking for the domain here, we're looking for the real domain. So we have to think and subtract our 4 from both sides. And we're going to end up getting x is greater than or equal to -4, which is simply choice D. So this was just remembering that square root functions have got to be positive radicands. Number 4 says, which inequality represents the graphed solution set? Well, right away when you see a dashed line, you know it's going to be either less than or greater than. So we could start by simply ruling these out automatically. Okay, again, greater than or equal to or less than or equal to are solid lines. So it's either choice A or B right off the bat. And at this point, I would simply just test a point. The solution is in this upper region over here, so test a point in this upper region. So pick any point up here. Let's say this point right here that happens to be in the region and on one of our hash marks. So that point is 4, 2. So again, we're testing the point 4, 2 in our equations. Well, let's test it in part A. If we test 4, 2, this becomes 12. This becomes 10. 12 plus 10 is less than 15. Is that true? Well, that means that 22 is less than 15. That's not true, so choice A is not our answer. So clearly, it's going to be choice B. And if we tested that point, we'd end up getting the same thing, 22 and 15, but simply look at the sign here. The sign here is greater than. So this would read 22 is greater than 15. So if we tested this point right here in the second equation, it would hold true. Let's take a look at the next one. Given the function, or given the equation y equals x squared minus 2x plus 4, this is a relation for now, with the domain of -1, 0, 1, and 3, find the range. And then finally, is y a function? So is this relation here, this relation right here, is it a function? So we have to go ahead and just simply plug in. So you could either go to your calculator and type in this relation, x squared minus 2x plus 4, and use a table of values, or you can just make a quick table of values with domain and range. The domain being these 4 values. The range, if we plug in, we end up getting 7, 4, 3, and 7. Now, these are my range values right here, okay, which is why the range, as you can see, is stated this way. I don't have to repeat the 7. Once it shows up once, and we know it's in the range. Now, here's the part. It says, is it a function? It is a function, and most people got confused because they saw this repeated 7, but that has no effect on the problem. Remember that it's the input that matters for a function. If an input has more than one output, but there's no input that's repeated here, so negative 1 has only one output, 0 has only one output, 1 has only one output, 3 has only one output. So every input has one and only one output, therefore, yes, it is a function. Now, you could also graph this to see it. And those who graphed it have to remember to use the vertical line test, not the horizontal line test. So negative 1, 7 is up here, 0, 4 would be like here, 1, 3 would be here, and 3, 7 would be up here. And we'll notice that if we put a line on this anywhere, let's take a look if I can pull a line up for us. Okay, we take this line, we'll see that it passes the vertical line test no matter where it is. There's only one intersection for each of these. So this is indeed a function. Questions 6 through 11 tell us to use f of x and g of x as defined there, and to find the value or expression in simplest form of each of the following compositions. So what we're doing here is remembering that these are definitions of our functions. So we've got a definition of f of x and a definition of g of x. And part 6, or number 6, asks us to find the value of the function f. So find the value of this function when x is replaced by negative 2. So we are literally replacing this x with a negative 2, and we're going to be determining what the value of the function is. So let's go ahead and do that. So we write the function, wherever the x was, we can leave a blank. And remember that we're going to plug in negative 2 in for that blank, because that's what number 6 is asking us. Find the function value f at negative 2. 2 times negative 2 is negative 4. Negative 4 minus 3 is indeed negative 7. Same thing for g of 5. So we write g of x out. Now g of x is x squared minus 3. So this is really some quantity minus 3. But remember that x is being replaced by a 5 in this problem. 5 squared is 25. The 5 comes from here, by the way. 5 squared is 25. Minus 3 is 22. Now, numbers 8 and 9 are the trickier ones because these are our real compositions here. We're doing g of f of negative 2. So we're doing g of whatever this is. That's what we're really doing in this problem. But we need to figure out what this is. So let's start by doing f of negative 2 on the side, and then we'll plug that number in right here to see what we can put in for g. So f of negative 2, if you can notice from number 6, happens to be negative 7. If you go back over here and look, we did f of negative 2. That is negative 7. So really, this just becomes negative 7. And we can test that, obviously. We can do 2 times negative 2 minus 3, which still, again, is negative 7. So this is really telling us, let's erase this here. Let's show what we're going to talk about. This here is really telling us g of whatever this is, but this is negative 7. F of negative 2 is negative 7. So let's replace this with a negative 7. So what we're really doing in this problem is g of negative 7. Now g of negative 7 means we're going to plug in the negative 7 here. So we're going to have negative 7 squared minus 3. It's going to be 49 minus 3, which is 46. The answer we get here, 46. The same thing goes for the next part, but we don't happen to have g of negative 2. So let's start by finding g of negative 2 first, and then we'll go ahead and plug that into f. So let's find g of negative 2. That's going to be negative 2 squared minus 3, which is really just 4 minus 3, which is 1. Again, what am I doing here? I'm plugging in this negative 2 in here for that x, and this becomes negative 2 squared, giving us 1. So g of negative 2 is 1. Again, g of negative 2 is 1. So what we're really doing here is this. We're saying, well, we want to really find f of 1, because we're replacing this g of negative 2 with the number 1, its value. So let's figure out what f of 1 is. Well, we're just going to plug a 1 in up here for x. So we get 2 times 1 minus 3. Well, that's just going to be 2 minus 3, which is indeed negative 1. The next part tells us to do g of a. Well, a is just some variable or some quantity or some number. It doesn't really matter. We just plug in again. So this earlier, remember, this is g of x. So we want to just plug an a in wherever there was an x in the function. Well, the x only occurs here. So this simply becomes, instead of x squared minus 3, it just becomes a squared minus 3. Again, all we're doing is taking a and plugging it in for x, because it's taken the place of that x now. So an a would go in here, making this a squared minus 3. The last one's a little trickier, because we're taking f, that function, and replacing this x with b minus 3. So see here, okay, right there, that x, we're going to be taking this x right here and replacing it with b minus 3. So this becomes 2 times the quantity b minus 3 minus 3. And that's right here. 2 times the quantity b minus 3 minus 3. Well, this becomes 2b minus 6 minus 3. And minus 6 minus 3 is minus 9. So this results in 2b minus 9. So you're taking an expression, b minus 3, and plugging it in for x. Let's take a look at number 12 now. Number 12 asks us to use elimination to find the solution to the system of simultaneous linear equations. Now again, elimination, not substitution. So make sure you use elimination when asked to do that. Then a follow-up says, what will these lines look like if graphed? Now, taking a look here, we're going to see that if we multiply this equation by negative 2, we'll end up with a negative 10 here. So it'll cancel with this negative 10. So let's go ahead and do that to eliminate x. So we'll multiply the first equation by negative 2 and add the second equation to it. So if we multiply this all by negative 2, this is going to become negative 10, negative 20, negative 22. Negative 10, negative 20, negative 22. And then to that, we're going to add the second equation. So we're going to add this second equation here. And what we'll notice is that, yeah, it does cancel our x's like we wanted to, but it happens to also cancel the y's. So we get 0 and 0. So we get a 0 over here, and this becomes negative 5. Well, 0 does not equal negative 5. That's a contradiction. So there is no solution to this system of linear equations, and therefore these lines are indeed parallel. Please remember that lines that are parallel will never intersect, and therefore there will never be a solution, because the intersection is analogous or is a representation of the solution to the system of linear equations. Use your graphing calculator to find the intersection of the two lines. Show a rough sketch of it on the coordinate plane, indicate what you entered into your calculator on y1 and y2, and indicate the point of intersection that you find to the nearest tenth. So the first thing to do for these is to solve for y, because you have to do that if you're going to use your calculator. So the first one, we're going to subtract x. We're going to get 3y equals 3 minus x, and then let's divide by 3 to get y by itself here. So we get y equals 3 minus x all over 3. That's this right here. The second one, we're going to go ahead and add 3x. So we have negative 4y equals 8 plus 3x. And then we can divide by negative 4, giving us y equals 8 plus 3x over negative 4. That's this right here. So that's the first part. Now, you need to enter this into y1, enter this into y2, and you'll see this graph here. This is what it will look like on your calculator. And what you're going to need to do then is to find the intersection. So you press second, and then you're going to press the calculate function, which is above the trace key. It's the second command on the trace key. So press second trace, and that'll bring up a list of calculations you can do. And the fifth one down should be intersect. If you hit intersect, it's going to say first curve question mark, and it's going to put a little cursor on the first curve, whichever one you happen to put the first curve on, and it might be right here. And all you need to do is just move the cursor over so it's somewhere in this area. Hit enter. Then it'll say second curve question mark. Move the cursor over until it's around here. Hit enter. Then it says take a guess, meaning guess the actual answer. Just hit enter on it. And they'll give you the exact intersection here. And at the bottom of your graph, it'll display x equals negative 7 point, and it'll give you all the decimals, and y equals 3 point. And to round to the nearest tenth, it's negative 7.2 and 3.4. Again, in order to do this, you need to be able to go through the steps on your calculator. Now, when it asks you the first and second curve and to move the tracer over, technically you don't have to do that because there's only one intersection, and the calculator is going to know where to find the intersection. But if you had a graph that looked like this, like a parabola with a line, you have two intersections. So that's why you take a guess, because it doesn't know which one to pick, like which one you're looking for. So when it says guess first curve and guess second curve, for an example like this, you'd have to put the tracer near whichever one you want to guess toward. Okay, but again, for this problem, it doesn't really matter what you choose for your first and second curve and your guess. Question 14 says to solve for r in terms of h by using substitution method. So substitution method, not elimination method. So the easy way to do this is to realize if you're solving for r in terms of h, it means get rid of the k. So let's solve for k in either one of these equations. Well, it's easier to solve for k in this first equation because everything happens to be a multiple of 6. So divide everything by 6 in the first equation. So divide this side by 6. This becomes 2r and this becomes a 3. So this is solving for k in the first equation. Now we can take this algebraic expression for k and substitute it into the second equation here for k. So that's what this is showing right here. So we rewrite the second equation, we plug it in, and this is what k was a moment ago. And now all we need to do is simplify. This will become 4r plus 6, that's this right here. And then this becomes 4h equals 4r plus 11. Okay, if I were to write it out in simplified form, 4h equals 4r plus 11. And then we'd have to go ahead and subtract 11 and divide by 4 to get r by itself. And this is what you get for r, which if you would like to can be written like this. Either expression is acceptable. Number 15 says to solve the system using any method and giving the hint that let x equal 1 over u and y equal 1 over v. This helps you to make it look like a standard system of equations. So if you think about it, write this as 4 times 1 over u. We did this example in class. Write this as 3 times 1 over v and carry down the 3. Then here, write this as 6 times 1 over u. Write this as 5 times 1 over v, and that equals the answer of 4. Now 1 over u is really x, so we put the x in there. 1 over v is really y, put the y in there. Now you have this system, and since it says any method, once you get a system, use the matrix. It's so much easier. Now a matrix solution to this will give us answers for x of 3 halves and y of negative 1. But remember that this was our let statement in the beginning. So if x is 3 halves, it means that this is 3 halves. So this becomes 3 halves equals 1 over u. And over here, this becomes negative 1 equals 1 over v. And if you want to go ahead and solve for u on the left-hand side, we need to think about the fact that we need to take the inverse of both sides. So this becomes, if we flip the u side, we have to flip the other side. So u equals 2/3, or u over 1. And over here, the same thing. Flip the right-hand side. This makes that v equals negative 1 over 1. So in the end, this one doesn't change. The v is still negative 1, but u ends up being 2/3, not 3 halves. So these are our solutions. U equals 2/3 and v equals negative 1. Number 16 says to graph the system of inequalities in the coordinate plane, shading the solution to the system and labeling this region S. And the hint is the big part here. To find the solution first of the first two inequalities and then apply the domain and range restrictions from the last two inequalities. So the first two inequalities here, we're going to see this one here and this one here. Now, you're more than welcome to graph this on a calculator. Nothing said you couldn't. So you could start it by writing them like this and solving for y in both cases. And that's a good way to do this. And the reason you'll notice this is greater than here is because when you solve this one here, you need to multiply by 2 to start. So you get 2 plus 2/3 x less than y. But if you think about it, that's what this really says right here. Because I flipped the whole equation around, put y on the other side and put the other stuff on the other side. The inequality has to flip also. So if I were to read it from right to left, it would be read as y is greater than 2/3 x plus 2. So y is greater than 2/3 x plus 2. Okay, here it's very simple to solve for y. Just move the 4x over and then divide by 2. This is what you can end up getting for this one. So here's these two lines. Y less than negative 2x plus 5. Well, here's right here. This is negative 2x plus 5. It's a negative slope clearly, and there's a y-intercept of 5. And we're going to see that if we tested the origin would be true. So we would start by shading on this side of that line, of that dashed line, that first one. Then we would move on to y is greater than 2/3 x plus 2. And that looks like this right here. Here's the y-intercept of 2, and here's the slope of 2/3. Okay, here's the y-intercept of 2. Go up 2 over 3, up 2 over 3. Here's our slope. So this is the second inequality here, and it's dashed again. It's dashed because it's just greater than. Now we need to check a point on this, so we check either a point above this line or a point below this line. And if we check the origin and plug the origin in here, we get or 0 is greater than 2. That's not true. 0 is not bigger than 2, so we don't shade. We do not shade this side. We have to shade up here, and that's going to look like this. Okay, so already our solution region is going to be, and I'm just going to quickly highlight this in the cursor, this is our solution region right here. This is only the solution to one of the inequalities. This is only the solution to one of the inequalities. This is neither an equality solution. This is both solutions up here. So it looks like this cross-hatched region is our answer. But we have to realize that we have to apply our domain and range restrictions. Well, x has to be greater than or equal to negative 5. So here's negative 5 for x, and x greater than or equal to negative 5. Well, greater than or equal to means solid line. So here's the line, x equals negative 5. Here's the line, y equals negative 4. So those are these two lines here, and they're both solid, but we want it to be bigger than negative 5. So everything bigger than negative 5 means now that we cannot go to the left of this line. So we have to remember that everything in our answer is going to be to the right of this line. So it's going to be all this stuff to the right of that. Okay, greater than negative 5, and everything down or below negative 4 in the y direction. So this is all going to be our answer for the y direction. The only region that has all of these crosshatches are right here in this little quadrilateral. So again, this whole region will be our answer, but everything has to be lower than positive 4, lower than or equal to positive 4 in the y direction, and everything has to be bigger than or equal to negative 5 in the x direction. So when things are greater than negative 5, it means from negative 5 to the right. When things are less than or equal to negative 4, it means from negative 4 and down. So it ends up that this is our solution region. Number 17 is asked to state the domain of each function, and now we're looking at rational functions here where we have a denominator, and we have to remember that the denominator cannot equal 0 or else the function is indeed undefined. So for this problem now, we have to go ahead and say, well, what can this not equal? It cannot equal 0, so that's this first line right here. The denominator, x times the quantity x minus 2, cannot equal 0. Well, what causes this to not equal 0? That means that if x were 2 there, 2 minus 2 is 0. So that's going to screw it up. So x can't be 2. And then if x were 0, it would make this whole thing 0 because it would be 0 times negative 2, which is still 0. So x can't be 0 and x can't be positive 2. So the domain is all real numbers except that x can't be 0 or positive 2. Now this one is a little bit trickier now. We're going to notice that we have a square root. So traditionally for a square root we say that the radicand has to be greater than or equal to 0 because the square root can't be negative. But because it's in the denominator, it can't be equal to 0. It has to be just simply greater than 0. So we erase the equal to part and just write 3x minus 18 has to be greater than 0. Again, it can't be negative because it's a radical. It can't be 0 because it's in the denominator, so it's got to be only positive possibilities. So we just set that or greater than 0 and solve for x. Move 18 over by adding it. 3x is equal to 18, and then we just simply, greater than 18, and then we simply divide by 3, giving us x is greater than 6. So the domain is the numbers x greater than 6. Next, we need to simplify, and again, as we're taught in class, we should rewrite this as adding the opposite, and that's what you're seeing right here. So we make this a positive sign, make that a negative, make that a positive, and we'll see those changes right there. And then simply underline your like terms. Those are like terms, well, they cancel. X squared and negative x squared don't cancel each other out, so we're not going to have a x squared term in the answer. Then we'll notice next that we have this 4 and this 2. Together they give us 6, and this negative 3x just gets carried over as a negative 3x. In the second part, we're simply adding two polynomials, so this is just looking at like terms. These are like terms. X cubed plus 2x cubed is 3x cubed. 2x squared has no like term in the other one, so we just simply put the 2x squared here. Then next we have a negative 5 and a positive 8. Well, negative 5 and positive 8 is going to give us a positive 3 at the end here. But we cannot forget about our other term, which is this 4x that has no like terms. That also just gets carried down. Finally, the last example, we have to remember that this is a distributive property. So this really means the following. X squared times x to the n plus x squared times x to the n minus 2 plus, minus minus x squared times x to the n plus 4. Now we need to remember our rules of exponents. When the bases are the same, you have to add the two exponents. So this becomes x, right? They're both the same, to the 2 plus n. X to the 2 plus n. In the middle term, we have x to the 2, x to the n minus 2. So we have to add these quantities together. So we're going to have 2 plus n minus 2. The positive 2 and the negative 2 cancel, leaving behind just the n here. So this becomes x to the n. And finally, at the end here, we're going to have a positive 2 and n plus 4, giving us n plus 4 plus 2, or n plus 6. This was simply remembering your rules of exponents. Okay, let's take a look at our 3 word problems here. The first one, it says Mr. Howell sends Christmas cards to his family members in America and his family members in Italy. It costs him $1 to send a card to anyone in America and $2 to Italy. If he sends 17 cards total and pays a total cost of $22, how many cards does he send to Italy? So how many cards does he send to Italy? So right away, x and y, our unknowns, need to be the number of cards sent. So x is the number of cards sent to America, and y is the number of cards sent to Italy. Altogether, it says that he sends 17 cards. So that means the number of these cards together has to equal 17. So we start with that statement. X plus y is 17. The amount of cards to America, the amount of cards to Italy equals a total of 17 cards. Now, each card costs $1 to America. So if he sends, say, 8 cards, it would be $8. But to Italy, it's $2 per card. So if he sent 8 cards, it would be $16. So the cost to Italy is really double the amount of cards he sends. So just to be hypothetical with this, let's say that, it happened to be the total 17. Let's say it happened to be 8 to America and 9 to Italy. That means that this would cost $8, but this would cost $18 because it's $2 per card. But this does not add up to the total of $22. So that's clearly not the answer, but we can see that the Italian cards and the American cards, the Italian cards are getting doubled to get the cost, but the American cards you just multiply by 1 because it's $1 per card. So the American cards are just x, but you have to double the amount of cards you send to Italy to get the cost. So x plus 2y equals 22. Now, again, solve these using a matrix. You may use a matrix once you've set them up. So at this point, you solve this with a matrix, giving x equals 12 and y equals 5. Therefore, since y was the number of cards sent to Italy, he sends 5 cards to Italy. Problem 20 says Hannah paddled down the Hudson River for 4 hours with the current. So she's paddling this way to move her that way, and the current is helping her out. Okay, she's paddling, and the current is helping her out. Then she turned around and traveled up the Hudson River for 5 hours against the current. So now she's traveling this way, but the current is still pushing this way. So let me highlight the current in red. So the current of the river is always flowing this way, okay? But initially she's with the current, and then she's against the current. And clearly it's obvious because it takes her longer when she's against the current. But she ends at the same point she started from. Now, if the full round trip was 40 miles, so 20 miles each way, what was her paddling speed and what was the current's speed? So if we're looking for her paddling speed and we're looking for the current speed, let's use those variables. So x is the paddling speed and y is the current speed. Let's remember that distance equals rate times time. Well, either way, for the trip, the distance is 20 miles, so it's both going to be 20 miles for each equation. But the rate is going to be different. The rate of traveling here is her paddling speed plus her current on the way there, or plus the current speed. And on the way back, though, it's her paddling speed minus the current because she's working against the current. So that's what you're seeing here. So these are the rates on the way there and on the way back. And then on the way there, she's traveling with the current. It only takes her 4 hours. That's the time that's going to go in here. That's where this 4 comes from here. And then this 5 right here comes from the fact that on the way back, it takes 5 hours. So the easy way to solve this is to divide by this 4 and divide by this 5 in these equations. So dividing this by 4, right? 20 divided by 4 here. Let's divide both sides by 4. You get a 5. And divide this 20 by this 5 to get rid of it. You get a 4. So your equation is reduced to simply this. And if we solve this by a matrix, you end up getting 4.5 and 0.5. So her paddling speed was 4.5 miles an hour, and the current's speed was 0.5 miles per hour. Question 21 says, at a hero shop, 2 sandwiches, a bottle of water, and a bag of chips cost $15. A sandwich, 2 bottles of water, and 4 bags of chips cost $14. And finally, 3 sandwiches and a bag of chips cost $19. What's the cost of each item? So since we're looking for the cost of each item, let's make those our unknowns. Therefore, x is the cost of a sandwich, y is the cost of a bottle of water, and z is the cost of a bag of chips. So our equations become the following. Okay, and this is very simple because of the fact that we have, it says, two sandwiches, a bottle of water, and a bag of chips. So 2 sandwiches, a bottle of water, and a bag of chips. And that's a total of $15. Second, we've got a sandwich. Now we've got 2 bottles of water and 4 bags of chips. 1 sandwich, 2 bottles of water, 4 bags of chips, cost a total of $14. And then finally 3 sandwiches and a bag of chips. So 3 sandwiches and a bag of chips cost $19. Noting here that there's no y. So that's where the 0 is coming from. And then we can simply solve by matrix. Solving by matrix here, we're going to see that when we use the row reduced echelon form command on our calculator, RREF, we end up with this 1s in the pivots and 621. And therefore, the cost of a sandwich is $6, the cost of a bottle of water is $2, and the cost of a bag of chips is indeed $1. Number 22 says, g of x is a linear function, and g of 2 equals 4, and g of 6 equals negative 3. So let's start by stating the 2 ordered pairs represented by this information. And right away, this tells us that when 2 is plugged into the function for x, we get a y value of 4 out. So 2 comma 4 is the first point, and 6 comma negative 3 is the second point. Next, we need to find the slope between those 2 points. Well, slope, remember, is just change in y over change in x. So we do, again, y2 minus y1, that's right here, over x2 minus x1, giving us negative 7/4 for the slope. So already, just listing the points and slope, we're almost done. Finally, let's determine the correct function for g of x in mx plus b form. So we start by stating g of x equals mx plus b. Now we have to find out what b is really, so let's go ahead and pick one of these 2 points to plug in. It's easy to pick positive points usually, so the 4 is the y and the 2 is the x. So we plug the 4 in here for the y, or remember, g of x, which is really y, and we plug in the 2 for the x. So the 4 goes here, the 2 goes here, and if we go ahead and take a look at this and reduce it, we're going to end up with negative 3.5 here. So negative 3.5 is right here. We need to add it over. So we have 4 plus a positive 3.5, giving us a b value of 7.5. You can ignore this extra little b equals here, okay? So if b is 7.5, this is the answer, but with a b value of 7.5, so it looks like the following. And you can go ahead and check and graph that line and see that these points are both on it, and clearly the slope is negative 7/4. 23 says, at 10 a.m. a storage tank started leaking fluid at a constant rate. By 11 a.m. there were 1,500 gallons left in the tank, and at 3 p.m. there were 700 gallons left. We want to write a linear function to describe the situation using v of t for volume and t. Now, in this problem we have to start by saying, well, we really have a slope here because we have 2 points. So let's realize that 11 a.m., okay, 11 a.m. 1 hour has gone by, and we have 1,500 gallons left in the tank. So t represents our 1 hour. Then at, looks like 3 p.m., 5 hours have gone by, and there are 700 gallons left in the tank. So this is our time, and this is our volume, just like we're told to find a function for volume in terms of the time. So for this problem, we have to say to ourselves, okay, we have 2 points, let's find the slope. So the slope is going to be change in y over change in x. So 1,500 minus 700 over 1 minus 5. Again, y2 minus y1 over x2 minus x1. So that's what this turns out to be, and we get a negative slope, giving us a volume slope of a volume function of negative 200t plus b. To find b, though, we could figure out that b ends up being 1,700. How do we know that? We could plug in one of these points. So at this point in time, I would plug in the first point, plug in a 1 and a 1,500. So plugging in a 1 here, this becomes negative 200. And we plug in 1,500 here, and that equals that plus b. So simply add the 200 to both sides, you'll get b equals 1,700. So this is our volume function. Next, how many gallons were in the tank before it began to leak? Well, that's really asking us, what is the y-intercept? So in this problem we have, all right, at 10 a.m. the tank is still full, thus it has 1,700 gallons before it began to leak. Well, what is the starting value? Remember, starting value is the y-intercept. And why is the slope of the function negative? The slope is negative because it's leaking oil. So the volume is decreasing, so it's a negative slope. Remember, decreasing functions have negative slope. increasing functions are what have positive slope. If this were filling up, the slope would be positive, but because it's losing oil, it's going to be a negative slope. And then finally here, we're going to notice it says, at what time will the tank be empty? So they're saying, when is the volume equal to 0? Right? The tank is empty when the volume equals 0. So set the volume here equal to 0. So 0 equals this function, and that's what this says here. Add the 200t over, and then divide by 200. So you end up with 1700 over 200, giving you 8.5 hours. So when will it be empty? What's 8.5 hours? Well, you have to remember, we're starting at 10 a.m. So 2 hours later is noon, and then another 6.5 hours would be at 6:30 p.m. So when is this tank empty? At 6:30 p.m. We could find the volume of the tank at any given point in time. We could say, when does the volume of the tank equal 150 gallons? And all we have to do is plug in 150 gallons in for the volume to find out when that occurs.